Hello and welcome. We'll be looking at the bending stresses distribution diagrams, and as you can see, all the diagrams that we have here, they are the diagram for what our symmetrical section. While the other ones here, they are what unsymmetrical section. A symmetrical section is a section in which can be divided into two equal parts from the neutral axis. Either you are considering you are sectioning it in the x direction or in the y direction. They will always give us what they will always be the same. But if you look at if it's section, that when we say section, when you cut this in the x direction, you observe that we cannot have equal elements being produced here. But if you look at this, if we divide it into two equal parts, we are going to have all our parts to be what equal. All right. This symmetrical section, they are very important. We'll be using them in our subsequent formula, because we said from our previous video that a member, that is our beam, can be in rectangular form, can be an hollow rectangular, can be circular, can be hollow circular, can be high section, and can be any of these one below here. All right. So symmetrical section and unsymmetrical section, they are both applicable to what? To a simply supported beam. All right. So the importance of this section is that if you consider this diagram here is the stress distribution formula. That's our major target. All right. So from the neutral axis here, this is the point here, and if you keep moving on, you will see that bending stresses keep increases from the neutral axis, from the neutral point here. Look at it. You move from this point to this point, from this point to this point, from this point to this point, then on like that. You notice that the bending stress keep increasing. Exactly. And if you stand at this point again, you move downward, you observe that bending stresses keep increasing. All right. And again, we said that if you consider the bending of a simple supported beam, the bending of a simple supported beam is subjected to two types of stresses. The first one is the compressive stress, while the second one is the what? Is the tensile stress. The top part of our simple supported beam from the neutral axis is subjected to what? Compressive stress, while the bottom part from the neutral axis is subjected to what? The tensile stress. All right, so it shows that the top part here is going to be subjected to what? A tensile stress. All right, while the bottom part here is going to be subject to what? This one is subjected to what? A compressive stress, while this one is going to be subjected to what? A tensile stress. All right, and again, by the time we derive our formula for Flexural equation, we say that m over I is equals to stress over y. All right, so our y there is the distance of the outermost layer from the what? From the neutral axis. So it means that from this point to the the topmost layer, that is the outer layer, is going to be our what? Our y. So the value of our y here is going to be what? Is going to be, this place is going to be y subscript what? T. That is, it's telling us that this place is going to be y subscript C, while this place is going to be what? Y subscript T. All right, so this is for our stress distribution diagram. So similarly with this, we are going to have tensile compressive stress here. All right, while the bottom part will be subjected to tensile stress, and here we are going to have here to be what? Y subscript C. It is the distance from this point to this point, while the distance from here to here is going to be Y subscript what? T. All right. So and again, what we need to note here between the critical difference between between this symmetrical section and unsymmetrical section. Their major difference is that here the distance from the neutral axis from the outermost part or layer, anyone you want to say, will be equal for a symmetrical section. That is, our y subscript t will be equals our y subscript c. All right, so here we are going to have y subscript c to be equal to y subscript what t. That is the comprehensive the distance from the outermost part from the neutral axis due to compressive stress will be equals to the distance from the outermost the distance from the outermost part from the neutral axis due to tensile stress will be equal. All right, so that is what is there, but here it will not be equal. It's not going to be equal. All right, so this is the major difference between symmetrical section and what unsymmetrical section. So I believe we understand this little explanation. So this is just what we need to note here when it comes to what the bending stress distribution diagram for symmetrical section and then unsymmetrical section. All right, so we are going to be applying all of this stuff in our subsequent calculations, and trust us, we are going to be solving all the important calculations that you might come across in your various exams, ranging from GATE, any competitive exam at all. We are going to be dissecting them under this topic. All right, stay tuned for more important questions, important concepts. And if this is your first time of coming across our content, please do well to hit the like button and don't forget to subscribe, and don't also forget to drop a comment about our videos. Thank you so much.